All right, welcome students. And once again, we're going to continue on our videos here. And we're going to be introducing a new topic. And this topic is going to deal with what are called oxidation reduction reactions, or sometimes they're referred to as redox reactions. We'll use both terms as we go through this section here. And these basically are reactions in which you have a movement of electrons. They're connected to, if you remember, oxidation numbers that we talked about in a previous chapter earlier on in the year. And we learned how to use those, and we said that oxidation numbers describe the movements of electrons. We're going to use those again. I already told you in class that you need to be reviewing those rules and gave you a little handout for those. So we're going to kind of follow up on that, and I'll show you why you're going to need those rules in order to identify something as an oxidation reduction reaction. Oxidation reduction reactions are used in a number of different ways. Some of the things we'll talk about a little bit later on this chapter are things where, let's say, electricity is involved. So where there is a movement or a flow of electrons, because that's basically what electricity is the flow or movement of electrons through what we call a current from one end to the other, which would involve things like batteries. Batteries or voltaic cells are all based on the principle of oxidation reduction reactions. And so this is something that you come into contact every day, since just about all of you have a cell phone and you have a battery in that. Or if you drive to school with a car, or whatever else you might have that would require a battery, that would play a role in oxidation reduction reactions. When we use things like stainless steel or silverware or things like that that involve a coating of one metal on another, that is often what we call electroplating principles. And that involves oxidation reduction reactions. So there's a lot of ways in which oxidation reduction reactions tie in. If you dye your hair with some kind of bleach or something like that, or hydrogen peroxide or something along those lines, often that involves an oxidation reduction reaction. So there's all kinds of reactions that involve a transfer of electrons. So let's take a look at some of the basic definitions here so that we understand. First of all, what is an oxidation reduction reaction? They're reactions in which electrons move between atoms. So from your reactant side, whether you start with compounds or whether you start with simple elements, as those elements combine to form a compound, or as those compounds break their initial bonds and form new bonds, there would be a movement of electrons. And that could mean electrons being transferred, like in ionic bonds, or it could mean that electrons are being shared, but now they're shifting one direction or the other in a polar covalent bond. So this could happen in a number of different ways, but electrons are moving between atoms. Now let's define what each of these terms. You have two terms, oxidation and reduction. Oxidation is the loss of electrons from an atom. It is not necessarily the fact that there's oxygen involved. And that's something that sometimes confuses students, or students get hung up on. If they see a reaction and there's oxygen in there, they assume that, oh, oxygen, that must be what's being oxidized. The two terms are not necessarily related. So understand that oxidation is the loss of electrons from an atom. So electrons are moving away or shifting away from an atom. And the way we would tell this, if you remember, if we're using oxidation numbers, a positive oxidation number shows us that electrons are moving away, and a negative oxidation number shows us that electrons are moving toward an atom. Okay, our next term, reduction, is the opposite of oxidation. It's the gaining of electrons by an atom. And so you have oxidation, the loss, reduction, the gaining of electrons by an atom. Then you have two other terms that you will need to be familiar with. One is what's called the reducing agent, and this is the substance that causes other atoms to be reduced. And generally speaking, kind of the easy way to remember this and we'll go into this in more detail. Whatever's being oxidized will act as the reducing agent. Okay, and kind of the flip to that is true. There's also something called the oxidizing agent, and that is the substance that causes other atoms to be oxidized. And typically, whatever the oxidizing agent is, will be what's being reduced. And that makes sense because if you think about the reducing agent, it's the substance that causes other atoms to be reduced. Well, what is happening when something's reduced? It's gaining electrons. Well, in order for it to gain electrons, what had to happen? Something had to lose electrons. Okay, so the reducing agent will be whatever lost electrons in order to allow something to gain electrons to be reduced. And the opposite is true with the oxidizing agent. So those are the terms that you're going to have to know, and you will eventually be able or have to identify within a chemical reaction. So if I give you a chemical reaction and it is a redox reaction, you're going to have to be able to identify, well, okay, in this reaction, what's being oxidized, what's being reduced, what's my reducing agent, what's my oxidizing agent. That will be something on the test that I would expect you to know and be able to identify within the reaction. All right, I'm going to give you a sample reaction here. And if you notice up top there, this says identifying redox reactions. So we've talked about redox reactions here, and we've said that, well, they're reactions in which electrons, move. Okay, how do we tell that, or how do we identify that? Well, this is where we mentioned in class, and I mentioned at the beginning of the video that we use oxidation numbers, and this is where oxidation numbers are going to help us figure out, is this a redox reaction or not? Because at first glance, I'm not going to be able to tell. It's not, something doesn't stick out there in front that tells me, oh yeah, okay, this is a redox reaction. So I'm going to use oxidation numbers to kind of help me do that. And I'm going to put them up here for you in just a minute, and then I'll kind of talk you through why, just briefly, why those numbers are the way they are. And what we're looking for, okay, here's the key. You have reactant side and product side. You'll have certain oxidation numbers on your reactant side, and what you're looking to happen is, as the reaction takes place and those bonds are broken, new bonds are formed, is that you end up with a different set of numbers, or at least two of your elements, maybe not all, okay, but two of your elements, whatever's being oxidized and whatever's being reduced, that their oxidation numbers change. One number should go up and one number should go down. And we'll talk about which one's which here in just a second. So I'll put the numbers up here, and I put the numbers above each element there. And if you look at hydrogen there on the reactant side, both the hydrogens on the reactant side, they're +1. We know that because hydrogen is almost always +1. It's always +1 when it's bonded to a nonmetal, which both of them are, so that's easy enough. Chlorine we know is -1 because for a couple reasons. One reason we know that the sum of the oxidation numbers of a compound has to equal 0. We know that hydrogen's +1, so therefore chlorine has to be -1. Oxygen, okay, on the reactant side with water there, oxygen is always -2. So there you go. You've got your oxidation numbers on the reactant side. On the product side, hydrogen, again, always +1 whenever it's bonded to a nonmetal, which it is. Oxygen, always -2. So there you go. Chlorine, in this case, now it's not bonded to anything, but it does still have a -1. Okay, why isn't it 0? Okay, a lot of times we talked about that if you have an element all by itself or a free atom, it's 0. Okay, but if you'll notice, it has a charge. Okay, so that makes it an ion, and we said that whatever the charge of an ion is, that will be its oxidation number. Okay, the oxidation number of an ion is equal to its charge. So that's why it's -1 there. So that's the reasoning behind all of those. And then what we want to do is compare reactants to products. So do any of those numbers change? Well, if I look at my hydrogens, my hydrogen is +1 on the reactant side, product side, it's still -1. Matter of fact, let's highlight that or circle that here. So here I have my hydrogen, it's +1. Here it's +1. And then I come over to this side, and it's also +1. So no change there. Okay, and then I'm going to look at chlorine. Okay, so here's chlorine. Chlorine is -1. Here I come over to the other side, and it's also -1. So chlorine didn't change either. So I've got one last possibility. So I look at oxygen. Oxygen's -2 here, and over here, -2 as well. Okay, so none of them changed, and so as a result, I would say that no. Okay, so if I was to write a big no, this is not what we would call a redox reaction. And what tells me that? Well, because I didn't have any change in my oxidation numbers, that tells me there was no movement of electrons. Even though the compounds changed, the electrons really didn't shift per se. And so as a result, this we would say is not a redox reaction. Okay, so that's how I tell, is I use my oxidation numbers to find out, is this a redox reaction or not. Let's look at another one. Okay, so here's another reaction, and we'll do the same thing. We're going to go ahead and pull in our numbers. So here's our numbers, and you have +1 for potassium, and the reason why it's +1 is all the alkali metals are always +1. Oxygen is always -2 there on the reactant side. And so how do we find chlorine? Well, we could do it two ways. One way is the chlorate ion there, ClO3. We know that it's equal to its charge, which is -1, and so we could set up that equation. Or I know that the whole compound has to equal 0, and I know that potassium is +1 and oxygen is -2, and there's 3 oxygens, so that makes -6. Okay, added to +1, so that's now -5. And so in order for the whole thing to be 0, what does chlorine have to be? It has to be +5. And you can set up that equation if you really want to. I'm not going to draw it out here for you. Then I'm going to go to the other side. Potassium, it's an alkali metal, +1. Chlorine, this time, is bonded to potassium. And whenever a halogen is bonded to a metal, it's always going to be -1. So there we go. Oxygen is by itself. It's a pure substance. Pure substances are always 0. And so we assign it an oxidation number of 0. Okay, now let's take a look here real quickly. Here's potassium. It's +1. Here's potassium over here. +1, no change. Okay, so far not looking good. Okay, then we have chlorine here. Is +5 on this side. And over here it's -1. Okay, we did have some change there. Matter of fact, it went down. Okay, and we're going to talk about that in a second. Here we have oxygen. It was -2. Over here it's 0. Okay, and so we have two things here that changed. And you should always have two. You can't really have one that's being reduced and then you don't have anything that's oxidized, or you can't have something that's oxidized and not being reduced. They go hand in hand. If something's losing electrons, or electrons are shifting away, then you have to have something that's gaining electrons. So the two go hand in hand. You can't have one without the other. And that is important to remember. So now what I need to do is identify, well, what's what? I know that chlorine is one of my substances here. Okay, and chlorine is what's going to be reduced. Okay, so I'm going to write R here for it being reduced. How do I know that? Okay, well, if I take a look at my numbers here, I went from a positive number to a negative number, or just basically my numbers decreased or were reduced. That's an easy way to remember it. Okay, and so what does that tell me? That electrons, okay, shifted towards, okay, this substance. There was a gain of electrons. Here I have a positive number, okay, and then that number went to a negative number. What does this negative number over here tell me? That electrons shifted towards it. So this would be my substance that's being reduced because it's gaining electrons. All right, what's my other substance? My other substance that changed was oxygen. All right, oxygen, in this case, coincidentally, happens to be what is oxidized. So we'll write an O, okay, or put OX here for oxidized. Okay, how do I know that? Okay, because it went up in value, and so therefore it is losing electrons. All right, we'll stop there for today.